When we looked at scatter plots initially, right, we looked at the association, and so we kind of said, it's positive or negative, that sort of thing. And then later on, we got a little bit more sophisticated and measured the association using correlation, the correlation coefficient R, and actually what we calculated was what we had Excel calculate was the linear correlation coefficient. When we talk about regression lines, the least squares regression line in particular, we calculate a value called the coefficient of determination. It's symbolized by r squared, and it is connected to r. It is literally just the square of the correlation coefficient, and we call that the coefficient of determination. Okay? And what it measures, it's a little obtuse to think about. Okay? All variables, all things that we measure have natural variation to them, right? That's why we call them a variable. They can range in value, right? And so what this coefficient does is it measures the variation in y, our response variable, that can be explained using the LSR model. Now, not all variation can be explained using the LSR model, right? The other variation is more due to other phenomena. Okay, it could be natural variation or something else. Okay, what it is, we don't know, but at least we can account for some percent of the variation in our creation of the LSR model. Okay, one thing that we should be aware of is just kind of the connection between r and r squared. So in a previous video, right, we said that r is on this scale between -1 and 1, and then there's 0, and then there's kind of these markings 0.3 and 0.7. Okay, and so we use those to classify a correlation between two variables as positive, moderate, or weak, right? And so just as a reminder, we had this sort of classification pop up. Now, when we look at the coefficient of determination, r squared, that is literally the square of the correlation coefficient. So we can take the r values and square them, but what then happens is our scale gets kind of compressed in sort of a way. So our scale, if we think about squaring all these numbers, is going to live on a region from 0 to 1. Okay? And the boundaries that we use become 0.1 and 0.5. Okay, if you think about squaring 0.7, that's 0.49, about 0.5, and 0.3 squared similarly is 0.09, about 0.1. And so then our boundaries become weak from when r squared is between 0 and 0.1, moderate when r squared is between 0.1 and 0.5, and strong when r squared is between 0.5 and 1. Okay, and that's all the information we can tell because by virtue of r squared, when we square it, right, everything's positive. So we can't tell if we have negative or positive association. Okay, so that you might have to do a visual inspection of the data on. Okay, but so just so we're aware of the connection here. Okay, so to do this in Excel, again, we're not doing this calculation by hand. Let's pop over there and see how to get that r squared value. And so on a scatter plot, if you have the trend line inserted, again, for a scatter plot, you would just click Add Chart Element, add the trend line, and make sure it's a linear trend line. But you would just have to double click on the trend line itself. Let's see if I can do that. Yep. Oh, okay, let's try it again. Okay, trend line. Sidebar pops open, and then just make sure to select r squared. Okay. Now, there's also a way to do this without even making a scatter plot. Okay, in fact, it's really kind of fun. What you need to do is go into the Data tab, go into your Data Analysis Toolpack, and this thing is so lovely that if you scroll down to Regression, R, there's regression, click OK, and then it's going to ask for your y and x range. And so this is where your selection is key. So select your y values, which for us is the FAC gain. Select the x range, which is the NEA change. There we go. And then we're just going to select a region for the output range that is somewhere that isn't close to everything else. And then let's see, do I want any of the other options? You can. We haven't talked about any of them, so I would just go and click OK. Okay, and then you can see it spits out a ton of information, and most of it we don't really care for. What we do care about is right here. And let me highlight those. So in the very last table, it says coefficients, and these are the coefficients for the intercept and the coefficients of, and the coefficient of x. So if you look at those and compare to what is given on the scatter plot, they're exactly the same. All right, so either method works. All right, and so that's just, and so this one, if I look at r squared, right, this is 0.606, this corresponded to a strong correlation. Okay, and if we look back at our correlation value, this originally was strong negative. Okay, so that they're consistent. It's just now with the r squared, I would also need to go through the extra work of saying, okay, based on the scatter plot, it's a negative association, so it's a strong negative relationship between NEA change and fat gain. And that's all I'd have to do to discuss the correlation here. Okay, so with this, in this video we talked about the coefficient of determination r squared, compared it to r, and we'll be sure to use that in our upcoming analyses.